Good morning. My name is ILMA HUSSAIN and my roll number is 225040 and my topic for presentation is motion of a rocket. So the motion of a rocket is an example of the system of variable mass. This motion of rocket follows the Newton's third law of motion and the principle of momentum. Newton's third law of motion states that every action has an equal and opposite reaction. So in a rocket motion we consider that this is a rocket and it has a gas chamber. So, it consists of a combustion chamber in which liquid or solid fuel is burned. The heat of combustion raises the pressure very high inside the chamber, so the hot gases are expelled from the tail of the rocket in the form of a jet with a very high exhaust velocity, that is VR we will see further, and the rocket moves in the forward direction. So here there is a chamber in which fuel, solid or liquid is filled. When this fuel is burnt, that is when combustion takes place, then the hot gases increase the pressure inside this chamber. So due to high pressure, the gases are expelled from the tail of the rocket. That is, from here the gases are expelled at a very high pressure, and due to that high pressure the rocket moves forward. That is the Newton's third law of motion. It exerts the force of action on the gas jet in the forward direction. These are the internal forces in the system that is rocket and gas system. In the absence of external forces, the total momentum of the system that is rocket and gas is constant. The gas jet requires the momentum in the backward direction and rocket gets equal momentum in the forward direction. That I have already explained by the diagram. Now, let m be the mass of the rocket and fuel at any time t and v be its velocity. Let an amount of mass dm is ejected from the rocket, that is ejected from the tail of the rocket at time interval dt in the form of a gas jet. If u be the velocity of the gas jet, then its relative velocity to the rocket Vr is given as Vr is equals to u minus v, where Vr is the exhaust velocity. Now by Newton's second law of motion we have this equation we can make by Newton's second law of motion. M dv by dt equals to Fe plus Vr dm upon dt, where Fe is the external forces acting on the system and Vr dm upon dt is the force of reaction exerted on the system by leaving mass. The force Fe is the gravitational force and air resistance on the rocket. If we neglect the air resistance and change in gravity, if we are neglecting the air resistance and change in gravity, then we can write Fe is equals to mg, capital Mg. Now we will substitute the value of Fe in equation 2. So we will get m dv upon dt equals to mg plus Vr dm upon dt. If the rocket moves upward, then V is directed upward. मतलब V ऊपर जा रहा है and Vr G downwards. That is, they are in the negative sign. They will be taken as negative. Then we have, now we will substitute the negative and positive values respectively. M dv upon dt equals to minus mg minus Vr dm upon dt. Now we will divide the whole equation by m. We will get dv is equals to minus g dt minus Vr dm upon m. Now we will integrate this equation with certain conditions as listed below. When the motion starts at time t to t naught, when velocity is v naught and the mass of the rocket and fuel is m naught up to an arbitrary time t, we get applying the conditions in this equation, we get integration v naught to Vr v naught to v dv is equals to minus g integration from 0 to 2 dt minus Vr integration m naught to m dm upon m. Now we'll integrate this equation. We will get v minus v naught is equals to minus gt minus Vr log base e m upon m naught. Further rearranging this equation, we get v is equals to v naught plus Vr log base e m naught upon m minus gt. We will write this equation as equation 5. Now we see where t is time required for burning all the fuel, m is the final mass and v is the maximum velocity attained by the rocket. In this equation all these terms are listed below. Now we will neglect g. Neglecting g in this equation, we will get the rocket of motion equation, that is v is equals to v naught plus vr log base e m naught upon m. This is the equation for motion of a rocket.